At some point in our lives, we all act as teachers. Maybe you're trying to make sure your BFF doesn't fail algebra or helping your kid with their social studies homework. Or maybe you're a teacher who wrestles with classes of students every day. And if you are, let me just say thank you for doing that, because teachers rock and society would crumble without you. Regardless of who or why you are teaching, though, the goal is ultimately for your student or students to retain the information you're trying to pass on. And you might think you know how to make that happen, but it turns out that a lot of classic teaching wisdom isn't backed by science. Like, you might have heard that you should be super enthusiastic, but while enthusiastic teaching seems to improve course evaluations, including ratings of the textbook, weirdly enough, it doesn't seem to do much for students' grades. Or maybe you've been told that you have to tailor your lessons to fit your pupils' quote, learning style. Well, it turns out there isn't really any evidence that that's important either. But psychologists have been studying teaching for decades, and all that research has stumbled on a few tried and true methods to improve teaching. Some of them might surprise you, like that cramming is bad and quizzes are good. So today, we're going to be talking about 3 ways you can use psychology to be a better teacher or even a better student. One of the most well-supported tricks to up information retention is to use a technique called the spacing effect, or spaced practice. The idea is that if you have an hour to study, you will do better if you can split that hour up, like 30 minutes on 2 different days. And you might even want to space those days weeks apart. There have been hundreds of studies on the spacing effect. We've known about it since the 1880s. But one early example, published in 1925, showed it by having students try to memorize the ephebic oath, something every ancient Greek citizen knew, but no one in the study had heard before. Half the participants were read the oath 6 times in a row. The other half heard it 3 times each on 2 separate days, which were 3 days apart. When they were tested immediately after the readings, it seemed like having the study sessions all mashed together improved people's memory a little bit. But on a test 4 weeks later, the group who studied with a 3-day gap in between did much better. This seems to be a general trend, too. If you want to remember information for longer, space your studying out with bigger gaps. One study published in the Journal of Experimental Psychology General in 2011 recruited 335 students and assigned them to practice learning material according to one of 5 schedules. The shortest was to try to get everything done in about 10 days. The longest took about 38 days to study, with practicing scheduled about a week apart. And though everyone who spaced out their practice did better than a control group, those who spread out their study the most did the best on a test given 4 months after their final study session. This effect seems to work across all kinds of things you can learn, from memorizing facts to motor skills to classroom material. It even seems like rats, bees, and fruit flies learn this way. But it is not entirely clear why it works. One idea is that whenever you learn something new, you tend to think about it a few times later on for no particular reason. Memory researchers call this autonomous reactivation. When you space out your practice, you get more of this autonomous reactivation, which for your brain is just more practice. There's also the possibility that if you space out practice, you might be studying the material in multiple contexts, like if you're hearing about it at home instead of a classroom, or even just learning different things around it. That means you'll have more associations with the memory you have of the content, and that gives you a better chance of retrieving it at the right time. Another explanation is that when you learn something, you stimulate dendritic spines on your neurons in a part of your brain called the hippocampus. These spines reach out to connect to other neurons, and when you stimulate them, you get more connections that last longer, which improves your memory. And the hippocampus is one of the primary brain regions involved in memory, so the connections there matter a lot. The thing is, these neurons need a bit of time to recover before they can fire again in the same way. That bit of time is called a refractory period. And basically, when you study the same material right away, your brain keeps stimulating the neurons during that period, and that isn't as good for maintaining the connections with other neurons as stimulating them after they've had a chance to reset entirely. But research on neurons in the hippocampus is hard to do on humans, so those ideas are mostly drawn from research on rats and flies. Even if we don't know exactly why spacing works, your students, who probably are not rats or flies, can benefit from it. Like you can try spending more time in class reviewing older material, devote a bit of time each day to covering material that was first introduced yesterday or a week ago. There's some evidence that this really works in classrooms too. One teaching method called direct instruction focuses 90% of every class day on practicing older material, and it was found to improve kids' achievement test scores, particularly in a poor school district with historically low reading scores. If you're a student, this can help you too. The lesson is basically don't cram. I know, cramming for exams is just how it's done. I did it a lot, and it helped me when I needed it to, but it did not help me retain that information in the long term. So if you've got a test coming up in 3 weeks, you will probably do better to spread your study time out and do a little each week than to try to fit it all into the night before. And when you're doing that spread out studying, you might try spending a good chunk of it quizzing yourself. That's because of what's called the testing effect, or retrieval-based learning. Imagine you've got 2 hours to devote to studying something, and you're trying to decide how to split that up. You can either spend the whole time reading through your notes and textbook, or take half of the time and use it to quiz yourself on what you studied in the first half. Research shows you are probably better off if you actually spend less time studying and more time testing yourself, which isn't fun, because that's the part that's more stressful. But that's right, tests and quizzes are a good thing, and they don't just determine what you know, they actually help you learn. Though this is another effect we've known about for a while, a clear example of it was published in Psychological Science in 2006. Researchers recruited 120 students and had them all try to memorize 2 short passages. One passage they memorized by studying in 2 7-minute chunks, the other passage they were told to study for the first 7 minutes, and then they were tested on what they could recall from it for 7 more minutes. Then they got a final test on both passages. If they were asked to recall the passages 5 minutes later, just rereading the material for that extra 7 minutes did give them a slight edge. They remembered about 81% of the passage as compared to 75% of the passage that they read for 7 minutes and then were quizzed on for 7 minutes. But 2 days or a week after the study sessions, having a pretest improved their scores compared to the one that they just studied by about 14% at both of those time points. What's also cool is that effect isn't limited to what's on the tests. A study in Science in 2011 found that students instructed to self-quiz not only had better scores on a test of the material, they also did better on things that required them to make inferences from that material. The students also did better than a group that was told to study by creating a concept map of the material, a diagram that shows connections between ideas and how they're related, which is interesting because it tells us a little bit about why retrieval practice works. One idea is that this works because of elaborative retrieval. Basically, when people make a point of trying to remember things, they bring related ideas up in their mind along the way. The more connections they build with related ideas, the more likely they are to remember what they need when the time is right. That would suggest that if people are told to do that specifically, like by making a concept map, they should see the same improvement. But making that map wasn't as effective as just trying to remember as much as possible, even though it was better than just more studying. So another idea is that testing works because of episodic context, which basically means when you try to remember, you remember the context of when you learned it. And then you update that memory with the new context. Having 2 different contexts then makes it more likely that you will remember it. This was shown in a study that manipulated the pretest in an odd way. Participants who were trying to memorize a list of words were given a pretest with word fragments they could fill in. Some participants were told to fill these in with a word from their list, but others were told to just think of the first word that came to them. And on the pretest, both groups used the words they were supposed to remember about 70% of the time. But then, in a final post-test, those who put effort into trying to remember whether the word was on the original list, as in the original context, did better than those who didn't, even though they both remembered about the same amount of words in the pretest. So it seems like something about pushing yourself to remember things as you first learned them is part of the process of keeping that memory for longer. So if you want your students to remember things, test them a lot. So you don't want to completely stress out your students, so you might want to try giving low-stakes quizzes throughout the class rather than one big end-of-the-unit test, for example. And if you're studying yourself, remember to test yourself on what you're learning. If you've ever had a teacher recommend that you make yourself a set of flashcards with a question on the front and the answer on the back, this is why. It works. If you don't believe us that quizzes are great, you are not alone. Several of these studies also asked the students which study method they thought worked best. Most of them were more likely to pick either repeated study or concept mapping, but then most of them would go on to do better with just the retrieval practice. Now, if you really want to take your teaching to the next level, you might try letting the students teach themselves. This is what educational psychologists call active learning, and it involves a variety of different things, from class feedback systems like clickers to more involved exercises like small group problem solving. A recent meta-analysis of 225 studies that tested active learning found that across several different fields, including chemistry, biology, math, physics, and psychology, using some kind of active learning winds up improving students' grades and lowering class failure rates. Students in traditional lecture classes had a 34% chance of failing, compared to only 22% with some kind of active learning. And it wasn't just because those classes graded differently. The effect held even for traditional exams. One of the more involved examples of active learning is called problem-based learning, which is exactly what it sounds like. You present a problem for students to solve at the start, and then basically go hands-off and let them figure it out. For example, you could give medical students a mystery case about a patient with a unique set of symptoms to motivate learning about the anatomy and organ systems associated with those symptoms. And some research shows that this kind of group can improve student achievement as long as you get some things right. You need to be sure that the students are actually collaborating, for example, and you need to provide some instruction for how to go about solving the problems. Also, active learning seems to work best if class sizes are small, like under 50 students. And some research suggests that really novice students might benefit from having a more structured learning environment rather than the freedom to solve problems on their own. But when it does work right, the reason seems clear. It is much easier to fall asleep in a lecture class. And I'm only kind of joking about that. Psychologists really do think that when you're required to come up with an answer yourself, you can't daydream as much. You need to focus your attention more, and that helps you remember the material better. The fact that problem-based learning works best in small groups of students also suggests that the social element is probably important too. But it could also work so well because students like it. In several problem-based learning and collaborative instruction studies, students report enjoying the classes more. That can improve their motivation to spend more time studying, and the more time students put into homework and studying, the better their grade. In fact, the amount of time spent studying makes such a difference that all the other research we've talked about so far has had to control for it. Basically, they have to look at how much people are studying, or else it throws all the data off. So yes, it turns out one of the best ways to be a better student is to study more. But if you got a set amount of time to teach something, spacing it out into several smaller chunks rather than one big one will help ensure your students remember what they're being taught. You should devote a good portion of the study time to having them try remembering the right answer, not just going over things over and over again. And your students will be better off if you ditch the lectures when you can and try some self-directed learning. The good news is that all of these techniques are fairly easy to implement with a little advanced planning. And now that you know the evidence behind them and why they work, you can be confident that that planning time will pay off both for you and for your students. Thanks for watching this episode of SciShow Psych, and thank you especially to our president of space, SR Foxley. You are the best, SR. Your continued support helps us make these educational psychology videos and all the other science content you see on SciShow channels. If you want to learn more about supporting SciShow, including how to become a president of space like SR, head on over to patreon.com/SciShow.